We've spent 4 videos talking about how to set exposure. We talked about aperture, shutter speed, camera sensitivity, and filtration. But we haven't talked about how to know what you should set the exposure at in the first place, how to evaluate your exposure. So let's backpedal just a little bit and pick that up. When you're measuring brightness, when you're measuring a camera's exposure on an electronic signal, there are 2 ways that we can approach this. The more common way, and the way that television engineers do it, is using a scale called IRE. IRE is short for the Institute of Radio Engineers, which is ironic because we're talking about television, right? But anyway, the IRE scale is just a percentage scale, except it starts at negative 20% and it goes all the way up to 120%. But your usable video range is between 0 IRE and 100 IRE. If your signal is darker than 0 IRE, there is no detail. It's just a pool of black. Likewise, if your signal is brighter than 100 IRE, there is no detail. It's just a pool of white. So between 0 and 100 IRE is where we want to keep the brightness range. And just as a reference, skin tone is around 50 to 70 IRE, depending on just how light or dark your skin tone happens to be. Sometimes brightness is also measured in RGB, and this is more common when you're working with computers. A lot of times editing software will refer to brightness in an RGB scale rather than IRE. RGB, you get 3 values, one each for red, green, and blue, and it runs from 0 being absolute black to 255 being 100% saturated, as bright as it can get on that particular color. Unlike IRE, you can't go lower than 0 or higher than 100%, which is 255. Whether you use IRE or RGB or even just percentage doesn't really matter. What matters is that we have an objective way to look at how bright our image is. So I'm going to talk now about 5 different tools that you can use to evaluate your exposure. More than likely, you'll only have access to one of these at any given time, maybe 2 of them, depending on the equipment you're using. But we'll go ahead and cover all 5 because these are the 5 commonly used ones. Let's start with the histogram. Histograms are very common on cheap electronics, and they're very common on cameras that have a background in photography. So if you're shooting with a DSLR or a mirrorless camera, probably you have a histogram as an option. Histograms do not offer much information at all. They are the least useful of the tools we're going to talk about, but they are useful. The histogram that you're looking at now goes from 0% or 0 IRE at the very bottom of the image up to 100% or 100 IRE at the top of the image. This particular one actually breaks out separate images for red, green, and blue channels. So you can see there's some overlap there, but you can also see independent signals for the red, green, and blue. The histogram does not tell you anything about what part of your image is bright or dark. All it tells you about is, on average, your picture looks this bright, this dark. So how much of your picture is really bright, how much of your picture is moderately bright, how much of your picture is dark, are represented by how far to the left on this particular histogram the bars reach. Some histograms are rotated so that they run left to right rather than top to bottom, but the idea is the same. So if we take a look at a histogram applied to this properly exposed exterior shot that I did, you've seen this shot before in the exposure videos. You can see that from the bottom to the top, it is roughly evenly spread. There's not a whole lot of area where it's brighter or it's stronger than anywhere else. From down near 0 IRE up to almost 100 IRE, there's a pretty constant amount of imagery there. This is typical of a properly exposed image. You should see the histogram filling up pretty much the available space between 0 and 100 in a typical image. Here's the same image overexposed by 3 stops. Notice how the histogram information has shifted up on the scale. There's almost nothing down there below about 20%. There are no blacks anymore. Everything is highlights and midtones. The highlights you can't really tell, but it's kind of compressed up there against the 100% mark. Here's the same image underexposed by 3 stops. look at how that histogram is all bunched up. All the information is bunched up in the bottom of the graph now. There's almost nothing, even in the midtones. Everything is just squashed down to the bottom. This is indicative of a really terribly underexposed image. The histogram, again, does not tell you anything about what part of the image is bright or dark, but it does tell you that the entire image is bright or dark or evenly distributed. Evenly distributed is what you're going for. Our next tool is called zebra bars. Zebra bars are a standard feature in any professional video equipment. And I'm very used to working with them personally, but they're really quite useful. The zebra bars are superimposed over the image you're looking at in your viewfinder. And they're animated. Sometimes people call these crawling ants. It's a series of diagonal lines moving across the screen, but they only show up in places where the image is bright. So in this particular case, as you're looking at this properly exposed exterior image, you'll see the diagonal lines marching across in the fluffy white clouds, but really nowhere else. This is appropriate because zebra bars tell us part of the image is bright, almost too bright. And the only thing in this particular image that should be really bright are those fluffy white clouds. If we take a look at the same image overexposed by 3 stops, that whole screen is crawling. You're seeing zebra bars on top of everything. They're on top of the blue sky, which is not really good. They're on top of the asphalt for the driveway that you see, and that's clearly not supposed to be bright, right? Zebra bars showing up over so much of the image tells you that everything you're looking at is really bright. And you have to ask yourself, should it be really bright? Should the green lawn be that bright? Should the driveway be that bright? Should everything in that image be crawling with zebra bars? In this particular case, the answer is no. Clearly, it's overexposed because there are too many zebra bars. On the underexposed image, we don't see any zebra bars whatsoever. This is to be expected because zebra bars tell us the image is bright, and there's nothing in this image that's bright, but there should be. Those puffy white clouds should be bright. So the fact that we're not seeing zebra bars in the puffy white clouds tells us it's underexposed. We need to open the iris or make some other change to make that image brighter. Zebra bars only appear on the viewfinder. They do not get recorded. They do not get output on the camera signal if you have it hooked to something else. They are only there for you. They're a tool for you to use. And again, just understand, the zebra bars only tell you when something is bright. You need to use your own judgment to decide whether or not that should be so bright. The next tool that we're looking at is called a waveform monitor. The waveform monitor probably gives the most information of any of the tools that we're using today. Not only does it show us brightness, it uses the entire brightness scale that's allowable for video. So from -20 IRE to 120 IRE, we can see when an image is overexposed or underexposed and by how much. But not only that, it corresponds going left to right with the video image itself. So you can see as you're moving across the screen left to right where the highlights and where the shadows, where the overexposed, where the underexposed parts actually are in the image. And I'll move around here just a little bit. You can see, as I'm doing fun stuff, how the waveform monitor, you can almost see the picture inside the waveform monitor, right? But there's a definite correlation between what's on one side of the screen and what's on that side of the waveform monitor and what's on the other side of the screen and what you see on the waveform monitor. Waveform monitors are not found in very many cameras. You'll find them in some, but they are found in a lot of production monitors. And they're also found as standalone devices. And if you're working in editing software, you'll be able to pop up waveform monitors to help you do your color correction and whatnot. So as we look at this properly exposed exterior image, again, if you go from left to right, you can see some correlations with the image and the waveform. You kind of have a sense of where the building, that center building is by looking at that rectangular blotch in the middle of the waveform monitor. You can see the brightness from the puffy white clouds. On the right bottom side, you can see a very strong line across the 0 IRE line, solid line of black. That's that column that's blocking the right-hand side of the picture. As we move to this overexposed image, look at how it's lifted off of the 0 IRE. There's nothing down there in the blacks. There's nothing below about 20 IRE or so. At the top, look at how everything is compressed against that 100 IRE mark. Now, this particular scope isn't showing me that it's overexposed. This is called crushing. We are crushing the whites. So, I mean, you can imagine that if you're lifting the floor closer to the ceiling and somebody's standing in there, right, they're going to get crushed, kind of like Star Wars garbage compactor style. There's so much that has been pushed up to that 100% that there's just no detail in it. So if you look at the sky, right, our puffy white clouds are just white crayon smears at this point. The sky is almost disappeared. I mean, you can see there's a little blue there. And there's just nothing that's black. If we look at the underexposed, 3 stops underexposed, you can see very dramatically, looking at the waveform monitor, that there's very little information at all except down at the bottom of the scope. And this kind of is like looking at the histogram, but the difference is going from left to right, we can see some details. So again, at the far right-hand side where that bar is at 0, that's still the column that's blocking the camera shot. And then that part in the middle that peaks itself up maybe to 15 or 20 IRE there, that's actually the sky. That's the brightest thing in there. So that's what we can see. The next tool to talk about is false colors. Now, false colors are a lot of fun, I think, to play with. And false colors are found in cameras that have cinematic backgrounds. So if you were shooting with a Red or an Arri or any of the really big name cinematic cameras, you would expect to see false colors. Even some Blackmagic cameras have got false colors in them. You can also find them in a lot of production monitors these days. False colors repaints the image. So the colors that you're seeing as you look at the viewfinder or the monitor are not, clearly they're not the colors that are actually there. But they replace the colors with colors represented by a brightness scale. So if you look at the scale that I'm using here, if anything is actually red, it means it's over 100 IRE. It is overexposed. As it gets close to that, it's orange, right? So up around maybe 95 IRE, everything turns orange. And then below that is yellow, a series of grays. When you get down to the skin tones, you've got these kind of pinks and greens in there. And then again, towards the bottom, you get into your blues. And then anything that's purple is actually below 0 IRE. So purple means it's, underexposed. It's just a pool of black at that point. It's kind of fun to look at, isn't it? A little bit trippy. Here with the properly exposed image rendered in false colors, you can see that there are indeed some really bright areas. So if you look at where the fluffy white clouds are, you can see they're getting into the yellow range. So they're really getting close to maximum exposure. Not quite orange, but almost there. If you look at the midtones in the sky, those mid-blues, you'll see they're rendered in the greens and the pinks, and that's pretty expected. And you'll also see that for the most part, there's very little purple on the screen. That right-hand column that's blocking our shot, the side closest to us is purple, so it's black, right, which is actually pretty much reality. And maybe the underside of those eaves is a little bit purple, but again, that's just black. That's a deep shadow, so there shouldn't necessarily be any detail there. If you look at the overexposed version here, look at how red that sky is. Everything up there is overexposed. Now, there are no purples, and there's really no blue to speak of in this image. There's nothing at the bottom end of the scale, right? So we have no dark information. We have no shadows. This is clearly far overexposed. If we look at the underexposed image, look at all the purple that we see. So much of that image is underexposed that, again, it's just going to be rendered as pure black. Nobody's ever going to see any detail there. We don't know if there are cars in there or people hiding or cats watching us. We have no clue what's there because it's underexposed. There's nothing. There's no information. The fifth and final tool that we're going to talk about is a light meter. Now, this is actually a little bit old school, but what I have here is a device that actually measures light. So if I hold it up close to my face and I push the button, it will sense how much light is falling on this little white dome. And then as I make my adjustments here, I can see that my proper exposure for this scenario is I should be shooting about f4 at 1/60th of a second. Or I could shoot at f5.6 at 1/30th of a second. It's actually what I'm doing. I'm shooting f5.6 at 1/30th of a second, which is the proper exposure. I have both zebra bars and a light meter, so I could have measured it either way. And in fact, I measure it both ways to compare the two to each other. Let me show you how this guy works. First, I'm going to set the ISO on the light meter to match the ISO on my camera. In this particular case, ISO 800. I want to make sure the light meter is in the same spot that my talent is going to be. I want to measure the light where my subject will be. All I have to do next is push the little button, and you will see the red needle starts to move, reacting to how much light is hitting the sensor. When I release the button, the needle will be stuck there, which is convenient for me. Now all I have to do is take a look at that reading, which is about 40. I turn the outer dial until the 40 lines up with the friendly arrow, and then across the bottom you can see all of my equivalent exposures, 5.6 at a 30th, and so on. You probably don't have one of these lying around, but if you're actually planning on becoming a world-famous cinematographer, or even just a real intense hobbyist, having a light meter is fantastic. There is no interpretation here, right? I don't have to look at the zebra bars and ask myself, well, should I be seeing the zebra bars in this part of the screen? I don't have to look at the waveform monitor and go, well, should that part of the image be exposed to ADIRE? This is a very simple, straightforward thing. It tells me how much light there is. I set my sensitivity, ISO 800 for this camera that I'm using right now, and it tells me at 5.6 at a 30th of a second. The other cool thing is that it's an independent device, so I can actually take light readings whether or not the camera's available. Right? So if I'm the person setting up the lighting before the shoot, my job is to have the lighting ready to go by the time the director of photography and the rest of the crew show up. I'm not going to have the camera there to look at the zebra bars or the false colors or the histogram, but I can have this, right? This is about $200 investment, which is not cheap, I realize, but this is bulletproof. I know what the exposure is. For where I am on this set, 5.6 at a 60th, 5.6 at a 30th is the way to go. And I can walk around the set taking measurements to make sure that my lighting is even or is not even. So we've talked about 5 different tools that you can use to evaluate your exposure. It does not matter which tool you have access to. What matters is that you use the tool you've got. Make sure that your exposure is proper. Make sure that your image looks as good as it can properly look. And use the tool to make sure that's the case.